Hello, my friends, wherever you find yourself in space and time. My name is Morten. Welcome to Making Sense of. And today we are making sense of what happened to Facebook. How can giant online services go offline for 6 hours without any real explanation? And what can companies do about it? Now, of course, I can't explain this. So I brought in some experts who can lend their expertise to this topic and try to figure out what this is all about. So I'll let them introduce themselves, going in a circle here. So let's start with Kumaran.
Hi guys, I'm Kumran Ponnambalam, Director of AI for WebEx Contact Center at Cisco.
And Lynn.
Hello, I'm Lynn Langett. I'm an independent cloud developer and architect, and also LinkedIn Learning author.
Great, and hi everyone, I'm Mike Chappell. I'm also a LinkedIn Learning author, and my expertise is in cybersecurity, and I am a professor of information technology at the University of Notre Dame's Mendoza College of Business.
That is a very long name for a college of business.
It is indeed.
So thank you all for coming to this and helping me make sense of all of this. The question that is on top of mind for me, and I think on top of mind for a lot of people, is how can giant online services like Facebook, Instagram, WhatsApp, and other services, because we've seen this happen to other services too, how is it that these giant services can go offline globally? Because you would think that that would not be possible.
Okay.
Anyone?
I don't think it's about somebody being giant or small. It's about how well you've architected your services to make sure that they are resilient to failures. And when we say resilient to failures, we are talking about a process going down, or a cluster of services going down, or a data center going down, an entire region going down. And how do you make sure that an issue in one area does not impact others? And also trying to look at, when you architect it, make sure that there are no single points of failures. And hopefully, when there are single points of failures, you make sure that there are very good plans to work around it. Especially things like having business continuity plans to make sure that when some parts of your services go down, how do you continue to do the services using alternative backups, redundant services, or and then the other thing will also to continuously test your business continuity plan to make sure that there are no unknowns in terms of your recovery process. So I think in this very specific case, it seemed to be that there is one configuration change, that a change that was introduced into the system. The change was to a central routing table, which is used for routing your request to various Facebook servers. It's kind of a single point of failure, looks like, and that configuration change messed up the table, so no requests were able to reach the servers. Now that was kind of the reason why the service went down. And that a lot of systems, right? A simple example would be like, if you have a database to store your username passwords, that service is very critical in terms of it's being live and being able to accessible, because if all your logins fail, nobody can access any part of your service. So not all services are the same. Some services are single points of failure, and some services are central and critical. And it's all about how you plan and then make sure that those services are up, and then your recovery plans are also in place to take care of things when things go down.
I think Kumaran makes some very good points there. What I'd add is, technology environments in general have just become very complicated over the years, and particularly in the sense of the dependencies that we have between systems. And like you said, Morten, there's not a lot of detail on what happened at Facebook. As Kumaran pointed out, there is this idea that it had something to do with their BGP routing, right? But there's not a lot of detail out on what happened under the hood there that caused this outage, whether it was an automated process that went astray, or whether somebody simply made a mistake, and then how that took down everything that they had, including their own internal systems. But I think I think one of the most important things to me is looking at all of these dependencies that happened. And there's a lot of stories out there about the things that were down alongside of their network connectivity, because they do everything internally, right? And they run their own data centers, they do their own BGP routing. And the rumors that we're hearing out there are that they were unable to get into their own systems because of this outage. So they were unable to get into the system that they would have needed to get into to make the update to put everything back online again, right? So it was kind of a circular outage where the outage took down the systems that they needed to access to bring the systems back up, but they couldn't access those systems, so they couldn't bring things back up. And that's one of the main reasons that this happened. And if you look even deeper in the dependencies, there are stories that their access card system, their badging system to enter their buildings, was also down. So the people who knew how to fix this perhaps couldn't physically get into the building to fix it. They couldn't access things over the network, and then their badges didn't work to get into the building to be able to physically touch it and try to fix it. So, in my view, one of the big takeaways from this is, when we have these complex environments, thinking really carefully about these dependencies and having that alternative plan of what if we have these cascading failures, how are we going to remedy that?
One of the best practices that has been followed, I've been seeing this in the industry for quite some time, is to separate your corporate network and corporate communication network from the service you are offering. Companies go to us for us, having them as different domains. Even when I was in a previous company, we had a .com domain for our company internal stuff and the websites, whereas the service was offered in a .net domain. So anything that hits the service won't impact the corporate network. In this case, they used a single network across the world for both the service as well as for the Facebook internal communications. They were using Facebook as the internal communication mechanism within the teams, like instead of using like Slack kind of thing. So when Facebook went down, even employees were not able to communicate with each other. They have to use emails as a mode of synchronous communication, which all this delayed, and even the badge access again hooked onto the same network. So everything is hooked onto a single network, and then that went down. It not only the service that broke, it also hindered any kind of recovery process, because everything kind of went. There was no backdoor. There was no duplicate key there.
So in addition to what's been discussed, one thing that really everyone needs to understand is we only know what's been made public. And in my work as in software forensics, part of the situation is that we shouldn't know everything that actually occurred. That should be part of the mitigation plan, because if everything's made public, then that opens an attack vector for subsequent attacks. So that's just something for all the audience to understand, that we might know what actually happened, but I doubt it, honestly.
True.
We know part of what happened.
Yeah.
Now that being said, what has been discussed about was really basically should be common sense around resilience, which is not having any redundancy on a single point of failure, is kind of shocking. And it that part of the story to me demonstrates an arrogance that I have seen, particularly in Silicon Valley, in that the engineering there is some of the best in the world, but it is a single point of failure. No matter how good it is, if it fails, it fails, right? And so this is something, because I lived in California for many, many years, that I think is particularly problematic in the Valley, because you have younger engineering talent who really hasn't had the maturity to see some of the incidents. Go ahead.
Yeah, one of the challenges here is also, right, as a company grows, the focus seems to be on problems that are happening a lot of times. And they tend to focus on those problems that happens every week, every month, and try to focus on how we work around this. These kind of problems that happens once in a lifetime, that focus is not there, because it's kind of assumed that it will always be there, or nobody is really thinking about it. There is usually something called as a business continuity plan. Even when you this happens when you try to settle to large corporate clients, they will ask you, like, what is your business continuity plan if you are on the cloud? and we have to present them a plan as to, okay, this is what we do it, and this is how we have the redundant network, this is how we transition over. One, we need a business continuity plan. Second is we have to keep doing a fire drill on it. That fire drill is also missing. Right? Yes, we had a plan, but we have to continuously try it out to make sure it works. There are no unknowns. Like, for example, in this case, even if they had a business continuity plan, would they have identified like the badge access issue or the corporate networks being down issue? Those are like unknowns which you'll only find right when you exercise it and do a fire drill, and that usually doesn't happen. Now, Facebook being a very customer focused application, it's a free application. There is nobody coming in. It's not like a application where customers are paying for it and they come and ask all these questions. So they may actually had a lighter time in terms of, okay, the service is down, there is no business lost or there is no revenue loss for their customers. But when you have companies who have these websites that do business, right, like Amazon or even like Salesforce, this problem is a really big focus area that we have to take care. Having a business continuity plan and exercising it repeatedly to make sure things like these kind of big failures, but not frequent failures, have to be taken care, because that attention is not there too.
Again,
yeah, go ahead.
Again, it's interesting to me how frequently the massive failures are caused by dependency on the external system, often DNS, and often configuration. And again, I really do think this was part of the overall cascading failures. We're just seeing a little part of it. But I see that companies devalue the basic network configuration work in favor of the more cool feature building, machine learning, that kind of stuff. And the network infrastructure is often seen as like plumbing. And so you have newer people who particularly need to have these written plans that are not only written, but as being discussed, tested on a regular basis. Another aspect of these sort of huge cascading failures that I think is really interesting is there's been some work in our industry of looking at other industries like the airlines or the medical professions, where they have multiple checklists, they test, and they have manual overrides. Again, I think something in our world of automation is preferred, and the human intervention is either not there at all, can get in the door, or it's just not seen with the importance it's seen, for example, in the airline, where you have the physical check of the doors, or in the hospital, where you have the handoff and you have the scanning of the badges and people talk to each other. And I think that, we see more and more, unfortunately, of these failures because the ability to pull this emergency switch is wholly missing in a lot of these plans. I've seen this, and I've said, where's the human? Well, we don't need that. We're automated.
Yeah.
Well,
it was interesting because during this situation, right, when everything was exploding and everyone was like, oh, how am I supposed to talk to my parents now, right? I wonder what my brother is eating for lunch. There was a rumor that appeared on Twitter for a while, and it was unsubstantiated enough that the guy who posted it actually took it down. And that also opens a whole path of like, but was he told to take it down or what was happening? But the rumor was that the configuration change had been done by an automated system. That some sort of a coding, like, I develop code for the web and I use automated systems constantly for integration testing, for everything else. And if you introduce errors into your system, the system will like deploy broken code, thinking it's fine, or even correct code into broken code and deploy it, right? And when I saw the rumor, I was like, that sounds completely believable to me. This sounds totally believable, and I totally understand why this rumor was like flying off the shelves. And it goes to what you're saying, because what I'm sitting here thinking is, okay, let's assume that this situation was a configuration change. Someone made a configuration change and it basically just deleted the Facebook domain off the internet for a while, and everything points at the Facebook domain and therefore everything goes down, right? That is a story that's being told. Someone did that, and how on earth was that even allowed to happen? Like how can a system be built so that someone can say, I'm going to configure that server? Because in my mind, there should be like 100 stopgaps before that happens.
So, I mean, I think, Morton, that's a really interesting question. And, whether or not it was a mistake that was made by automation or an individual, I think one of the key things here is not everything needs to be automated or to this extent, right? Like your BGP routing tables are something that don't change very often, right? So and maybe as a safeguard, one of the things you can do is take something like that that's so infrequently changed and fairly straightforward and leave it alone, and don't have systems that can reach in there and mess with things that are so very critical to how your service operates, right? So what are the boundaries around these automations and the types of changes that one person can make, right? So there's a principle in security that's used in very sensitive situations called two-person control. And like the classic example of that, if you think of like the movies, is exactly right. It's when you want to launch the nuclear missile, you need two people with two different keys, and the keyholes are far enough apart that one person can't reach them both, right? Yeah. So two people have to agree to do something. So for something like updating the BGP tables, well, that's the kind of situation where it's so crucially important that you get it absolutely right the first time, that you probably want that level of control to make sure that one person can't do it by themselves. They physically don't have the ability to make that kind of change without two people, turning the digital key at the same time.
So Lynn, because sorry, you understand some things about the cloud and stuff. This question from Drew is something that came up a lot in the conversations I had with people, that couldn't it just be separate VMs? Like if you take something down, isn't this all virtual anyway? Isn't it all in the cloud? Isn't there a way to just go and reset something somewhere and then just bring it back?
So there is, if you can log in, but from what we understand, as was said, that Facebook internal employee communication systems. So it was the physical door you couldn't get in, and it was also the Facebook employee systems you couldn't get in. Like people were using, it was reported, and again, we don't know, but it was reported they're using their Outlook accounts, their Gmail to try to talk to each other. So if you can change a VM, if you can access the VM, but if you can't physically access it or you can't logically access it, well then, you can't change it.
It's not a VM situation, right? It's getting to the VM situation is broken.
Yeah. So this is very much
from what we hear, the services were all up and running. There's no issue with the services themselves. The services, the instances did not go down. It is just the routing to those instances that was broken.
And so this kind of highlights this.
And there was only one path to get there. There should have been like a backup, a backdoor, something like that in these situations with some privileged access. That seemed to be not the issue, not the thing there. It's kind of surprising what is happening there, because these are things you would want to usually take care in a large application like Facebook.
Yeah, but I think this is an interesting story because it highlights this fragility of our online world, that even when you have something very, very big, if you go far enough down, at some point there has to be a single point of failure, because there has to be that point where the application interfaces with the web and people can get access to it, or it makes itself
right.
available.
So there's a couple things. First of all, there will be single points of failure, and as was said, probably shouldn't be automated. And second, understanding the attack surface, assessing it, downing it, the famous Netflix chaos monkey stuff, where they just let, simulate the downing of entire AWS regions randomly, so that they can have a response to unplanned events. But the problem with that is it's really, really expensive. And unless you are Netflix, what I've done as an architect with some of my enterprise customers is I will say, I want to do a little mini chaos monkey, because people actually need to feel the pain. And so I'll get permission, and then, get all the IT people who are really nervous, and I'm going to randomly down something, and we'll see how it works. And I find that is a really effective technique, because as much as people say they understand, they have to actually see it and see the cascading failures. And then they will accept the costs associated to creating these points of redundancy. But it's very unusual for a customer who hasn't experienced the pain from unplanned outage. In fact, that's one of the questions I ask customers where I'm adding some functionality. How many times have you had an unplanned outage? And they look at me like, well, everything works all the time. And I said, well, it does until it doesn't.
Yep.
So
Yeah, and this is a good path. Yeah, go ahead.
I was just going to say, I'd like to tie together a couple of threads there that I think are important. So, Kumaran mentioned the idea of having these backup plans of, what do you do if? And then Lynn, you're talking about how in most architectures, you're probably going to have some single points of failure, right? You can engineer around them. It gets expensive to engineer around them. And sometimes you're going to make a business decision not to do that because of the cost. So knitting those two things together is really important. Understanding what trade-offs you've made and what risk you've accepted. And then thinking through, in the chaos monkey spirit, let's make it 3 threads we tie together. What could possibly go wrong here? And if it does, what would we do about it? And doing those like war game style of simulations of, okay, well, if we lose access to this system through the front door because our BGP tables have been destroyed, we'll plug a dial-up modem into this thing, right? And here's the phone number that these people know how to dial, and somebody is going to be able to get in and fix the system, right? And having these in playbooks where we know, okay, maybe when we have a crisis, the situation we're facing might not exactly fit one of the scenarios that we've already thought through, but it's probably going to be similar to one of them. And let's get that plan, and then it'll give us some ideas on how we might quickly get things back up and running again.
Right. So this is a good transition point from what hypothetically happened based on what we know from the minimal information that's come out to say, okay, so I am a company of any size and I have an online service. What do I do to ensure or to protect myself as much as possible, both from something like this happening internally, like an automation failure or someone pushing a button they shouldn't or deploying some random code. We've all seen that, right? Like some entire online service going offline because someone entered the wrong code. In fact, I was on the Government of Canada's website yesterday and I found like there was a form I was filling out and it kept failing on me. And it was because there was an incorrect code in HTML. And as a web developer, I literally went in and I sent the post request manually through the browser to be able to bypass the system. But it was literally like someone had started an HTML comment and then not closed it properly. So part of the HTML comment was sitting in live text and it was crashing the form, right? And so let's start with that. Like, how do I, as a company, ensure that we don't have internal problems?
So risk assessment, you put resources to it. You evaluate, you sit down with the leadership in the company, both the business and technical, and you assess the system. First you understand the system. I mean, again, this is an area where I do quite a lot of work because people will call me after there's been an incident, which is unfortunate. I always joke around. You can either pay me up front or pay me after, and I'm going to charge you double. So one of the first things is we have to understand the current state of the system. I actually did one of these just 2 weeks ago, where the system was failing and they didn't know why, and they didn't know if it was a security incident or what was the problem. And a lot of times I find that there's not even a common understanding of the system. And architects have to draw a picture. I have to draw an architectural diagram that is consumable by everyone, but has enough detail that it's actually meaningful in terms of where the points of failure are, where the redundancies are. And then we have to discuss what the cost would be for mitigation and then do a cost benefit. How much would it cost, for example, to have redundancy across multiple clouds or multiple regions or zones? And how likely do we think that the system would go down? Now, some of it is guessing, but you might have some history. Like, has this gone down? Do you have, code deployments that cause it to, be more risky, or, they have more customers on it or whatever? Try to put a dollar amount on it, because in the end, it's a business. So if X goes down, how much do we think this is going to cost? And again, you can get the resources out of business when you present it that way, because you think, okay, if you're down for X number of hours, how much revenue you're going to lose. Then they're going to understand. That's what I have had success with.
So I think another crucial factor is thinking through the team that you have. And I think one of the key factors to getting all of this right is having a lot of wisdom in the room. And that can come in a few different ways, right? One is sort of the institutional wisdom that you develop. That some of it through like those war game style scenarios that I mentioned earlier, some through lessons learned. Right, I bet you Facebook has learned a lot about resiliency in the past week, and and they've thought through what went wrong, and I sure hope that wouldn't happen again there. But they're also taking the ideas and the generalized concepts that they've learned and applying them to other areas of their architecture, their infrastructure, their business. So that's one piece of it. What institutionally have we learned? What does Facebook or LinkedIn or whoever it is know about this from our collective experience? But then also there's the individual experience, right? Every organization's made up of people, and those people have been other places and done other things. So as those Facebook engineers spread out to other companies over time, they're going to bring that experience with them. And I think, all of us who've been around technology for a while have these battle scars that we bring around with us to everything we do, right? I think of many years ago, I was with a large government agency that had tens of thousands of employees around the globe. And they were using, I'm going to date myself here, a networking technology called ATM, asynchronous transfer mode. And they had a cascading switch failure, and it cascaded globally. And the entire organization had zero networking for a few days as a result of this. And it took some of Kumaran's colleagues at Cisco coming in and spending a lot of time and energy basically redesigning the network in a few days to get it up and running again. And if you look back at the major root cause of that was having duct taped and chicken wired a whole bunch of previously independent networks together over a long period of time until you finally reach the breaking point. So that's a battle scar that I've carried with me for 20, 25 years. And I think of it when I'm involved in projects even today, right? Of what situations could happen here that are similar to that situation I experienced 20 years ago, or other things that have happened in my career. And the more diversity you have on your team, and I mean diversity very broadly, you want the people around the table to have a lot of very different experiences, so that together all of their battle scars will help you build a more resilient infrastructure.
True. And I will also say that usually you need to have like a multi-tiered approach. The first approach starts at like prevention, like Lynn said, right? You have to make a risk assessment. You need to make sure that your architecture is well done and it takes care of all these issues. That is the first level, what you build. Second level is how do you test? I see a question in the chat which says, how did testing didn't catch it? Testing will only catch it if it is done in an exactly same environment as the production. If you try to cut cost in testing by having a much smaller environment that does not simulate your entire production, testing may not catch all the situations. So testing is the second phase. The third one is monitoring. You have to continuously monitor your production for these kind of failures through like an independent monitoring tool that can at least monitor and say, here are some things going on. Possibly there is a risk here, risk there. And the last part is recovery. You need to have a recovery plan, and you need to continuously do a fire drill of the recovery plan to make sure that you can come back in expected recovery times.
Yeah. So Mike, you've touched on something I think is really important here, which is a lot of these companies that become huge grow out of small things that slowly grow over time, right? And then maybe they find another company and they integrate, right? And build things up. And I can see just from having built networks myself in my house, from having worked in a TV station where we had to rewire things constantly, that there's this weird, like natural tendency for people to, instead of going, at this point, we need to re-engineer everything, otherwise it'll all collapse, to just keep plugging things into the routers. And then you get that single plug into the wall that connects to a router, and you have this crazy network that can easily go down. How do you know, it's a question for all three of you, but how do you know when to stop and say, we need to rethink this when you're growing?
Yeah, well, not to be a broken record, but I think that comes from that wisdom and experience, right? Of like, if we're all acquiring each other, and Lynn over there has her network up and running fine, and my network is up and running fine, and like we merge as companies, well, the easy thing to do is just say, boom, right?
Yeah.
We'll just connect these two things together, and that worked, right? So, oh, great. So when Morton comes along, we'll just go. I hope we're all arranged in the same way on everybody's screen, but we'll just plug that in because it worked last time, and it still works. But then when we want to get that way, Kumaran in here, that might be the tipping point, right? Mm-hmm. Now we have too many of these things that are like the daisy chain of extension cords plugged together, and you have one of these cascading failures. So I think there's not an easy answer to that of like when n equals 6, it's time to redesign. But I think it's when you look at your design with a lot of that experience and say, this thing looks like a bunch of extension cords plugged into each other. I think we need to sit down and rethink this and redesign it in a careful way before we wind up redesigning it in a crisis way.
Well, and to add on to that, I mean, Werner Vogels, the CTO of Amazon Web Services, said everything fails all the time. And I mean, it does. I mean, again, we all know this. It's not if it will fail, it's when it will fail and what you will do. And, to Kumaran's point, have you gone through a process? Have you tested some? Because you can't test everything. Do you have a response plan? And to Mike's point, do you have a playbook? Do you have a general idea that the person can even find, much less they've seen it before? I don't know. You guys have probably all run across. Oh, we have playbooks. Really? Where are they? Well, it moves to the bottom of the priority list because people don't want to think about it. And that's why, I said it earlier, but I will say it again. A technique that I have used is to create a failure. Mm-hmm. And it sounds very like arbitrary and contrived, but it actually helps make it physical to people. Like, oh, like now I'm going to do another one. No, stop. No. Make it real. Make it real.
I mean, that is what we do, right? We write tests for our code, right? That's test-driven development has become a thing that, well, not everyone, but it's become a thing that's more and more prevalent in the development industry, that you write a piece of code, you write a test for it to make sure like some data doesn't just break everything, right? But there's it feels like there's a culture thing going on. Mm-hmm. And you hinted to that, Lynn, that there's a culture in Silicon Valley of like, we make no mistakes or whatever. But I feel like for a company to be able to make these decisions, to say, we are going to write the playbook, we are going to do the testing, we are going to have resiliency and plans in place and do the practice of actually crashing our own service and then getting it back online. It requires a culture of, we are not just endlessly pursuing greatness going forward, but we're also careful about what we're doing here, right?
Yep. Yeah, the thing I want to kind of add is that, do we know when we have to redesign the system or re-architect the system? Usually the architects know it. And when there are too many bandages happening, there are too many workarounds happening, they do come up with and say, hey, I think it's time for us to rethink the whole thing and rebuild it. The challenge there is the cost involved in it. And then the management comes back and looks at the cost and this is exorbitant. We cannot, because what happens is if a system is up and running, you need an X amount of capacity to manage and maintain the system, to keep sustaining the system, running the service. And then now you see, I want to build a new system to replace it. That comes out of an extra budget. You can't like reuse the same team, because if you reuse the same team, you won't be able to either do the sustenance well or the new development well. Both of them will lag. Mm-hmm. But can you invest in a new team in terms of budget to do that? That's an exorbitant cost, which creates a lot of resistance from the cost side of things. So that is a thing which people continue to kind of grapple with, and usually you need like a really big hit in terms of your reputation, either through a failure or quality or whatever, for people to go and rethink and say, you know what, it's time to put a pause on it, and then we need to invest in rebuilding something.
Right. So this is how legacy debt.
Yep.
That's how legacy debt
comes in. Yeah.
So it's interesting. So I'm actually up in Fargo because, and they're okay, but one of my family members had surgery yesterday, actually, And so there's been some lead up to it and everything. So I've had some intense experience with the medical system because of this. And again, it really underscores to me how much work we have to do as an industry, because the physical checks, the double checks, the triple checks, the human and automation, not that the medical systems are perfect, but they are so much more resilient than our technical systems. And I'm not the only person who thinks this way. One of the, I don't know what he's doing right now, but he's works in Amazon. The guy's name's Adrian Cockcroft. He's one of the guys that built Netflix. He's been doing work on bringing lessons from medical profession, from airlines, transportation, from different systems into our industry, because I think it is a systemic problem, because we're a young industry, that we just don't have sort of much runway around the typical corporation operating like you're doing a major medical procedure. And as more and more of our systems are dependent on automation, whether it's to find out what our brother ate on Facebook or whether it's our energy grid, we have to mature as an industry. Because we can be annoyed by a Facebook failure, or maybe even lose some money if we're doing business there. But the point that Adrian and some other leaders in the industry are making is, as more and more of our world is automated, we could have catastrophic problems. Look at the energy problem we had in Texas, for example. That's an example. And we're going to have more of them until we learn as an industry that this is part of building software. This resiliency and the testing and the 4 steps that Kumran was talking about. This is not optional. This is not after you had an outage. This is professional software development.
I think this like links to something that I talk about all the time, which is this idea that software isn't just software anymore. It's often, it affects people's lives in a very real way. And this Facebook situation kind of illustrated how people think about this differs depending on where they are. Because when Facebook goes down, right? If you're in North America, people are like, ha ha ha, now all the anti-vaxxers can't do their research anymore, right? Meanwhile, in like parts of Africa where WhatsApp is responsible for like 70% of all internet traffic, they basically shut down their entire economy, right? Because everyone uses WhatsApp to transfer money and uses it for communication. In South Africa, people can do interactions with the government through WhatsApp, right? So if you want to renew your car license, or you want to do some sort of remedial task like pay some tax bill or whatever, you can do it through an online platform. And in yet other places in the world, Facebook has become the internet for them, because they have this Facebook Lite thing, and it kind of bypasses the complications of having very slow internet access. So when this trivialization of services going down and the developers going, well, it's a free service. If it doesn't go down, it is not going to hurt you. It doesn't really fly anymore, because it does hurt people.
I think one thing that what Lynn talked about in terms of the medical field, makes a lot more sense, is that in the medical field, the penalty for failure is really high. Right? If an equipment fails, it is going to have catastrophic implications for the company who made it. So that makes them, invest a lot more money in terms of making sure that their equipment does not fail in whatever way it is. In some of the internet applications that we have, that penalty is not that much. Even in the Facebook case, right? Loss of revenue, risk of lawsuits or any of that, there's not that much. So the focus is also not there, I would say, in terms of, okay, so what if it fails? We are down for a day. How much do we lose? That kind of a risk reward pattern do exist, and I think there has to be more penalties. At least I think it would happen on business applications, where if somebody using AWS for running their business and their service goes down, there is a penalty to pay in terms of money as well as in reputation. Then those kind of things may increase the focus on these kind of failures. Otherwise, businesses tend to be more focused on near-term problems, often repeating problems, than focusing on very long-term catastrophic problems like these.
I think this is kind of off the mark, but it's still relevant. I was my son really likes trains, so we were watching a documentary about trains, and they were showing the super high-speed trains in Japan, the Shinkansen trains. And I noticed as they were doing things inside the cab, right, to run the train, every time the driver did something, they would, turn a dial, and then they would point at it, and then they would pull the lever, and it would point at it. And then weeks later, I found a video of a Japanese airline where the flight attendant was closing the door. And again, it was like, you close the door, point at what you just did. Actually use your hand to point at the things. And I looked it up because I was like, this is clearly not a thing that a person is doing. This is a thing. And it turns out that they found psychologically, if you force yourself to point at what you just did, which sounds trivial, it makes you think about what you did. And it makes it very conscious. And I almost feel like that's what we need, is like, you're going to deploy something, type the deploy message and point at it so that you actually look at what you just did before you do it, so you don't accidentally crash the entire network.
Yeah, well, the other thing that we can draw from that example, Morten, is you always hear the announcement on the plane, flight attendants cross-check and prepare for departure, right? And it just flies through one ear and out the other. Mm-hmm. Cross-check, what that means is everybody check everybody else's work, right? Yeah. If you're the one who locked the door and shut that pressure seal or whatever it is, somebody else go over and make sure it's shut right? And I bet Facebook wish they had cross-check on their BGP updates.
Okay, so we have like less than 4 minutes left. What is the number one takeaway from each of you for anyone watching this?
I'm going to the theme that I borrowed a little bit from Lynn and talked about for a while, and it's having a really strong team, having a team with diverse experiences and creativity around the table who can bring their collective wisdom to the table when you're designing, when you're testing, and when you're responding to a crisis.
And I would say expect failure. It's not an if, it's a when. And you decide how you're going to respond. That doesn't mean you have to make everything redundant. You might choose not to, but decide, not just let it happen. Expect failure and decide what you want to do and test it.
Yep. I would kind of repeat the same thing, testing, monitoring, and have a recovery plan.
That's a good cohesive package right there. Everyone is in agreement. Okay. Thank you all very much for joining me for this. This has been tremendously enlightening. And I think everyone, all the people that are commenting in the section here and the hearts that I see flying all the time indicate to me that people are learning something from this. I unfortunately expect we'll see more of this kind of stuff happen in the future. And I hope that, like you were talking about, Lynn, that we will eventually get to a point where we start acting a little more responsibly about how we deploy things on the web, because it does have an impact on people's lives. And I do think we have a lot to learn from other industries, because other industries have gone through these, accidentally building bridges that fall down and stuff like that, that eventually will get there. But because of the accelerated phase of our industry, we also need to get there much faster.
Yep.
So and that's what we're all working on. So thank you very much for joining me. To all of you watching, I do these events every 2 weeks or so, and the whole point is to make sense of things. So if you see something in the digital world that you want to make sense of, tell me about it, send me an email, find me on Twitter, send me a message publicly, add it in the comments, do something to let me know. And I will track down people who can help make sense of it. So until next time, thank you to my panelists. Thank you to everyone who are watching this, and to everyone who will watch this in the future. Have a great rest of the day.
Thanks, guys.